Hello students, in this video we are going to study an important concept of graphs. Hope you have already learnt about graphs and its uses. Let us revise them actually. Now look at these two graphs. Both the graphs look quite similar. If we see the graphs, they look quite similar. Okay? In each case, the graph is divided into three parts, OA, AB, BC, and the three parts look exactly similar in two graphs. Now, if we look at their y-axis, if we look at the labelings done on the y-axis, we see that y-axis is not labeled very properly, but still in the first graph we can see the unit meter per second and we can see that one value is denoted by V0. It means that first is a VT graph. In the second graph, we have seen meter unit is mentioned and S0 reading is there. So S0 means it is an ST graph. It is a ST graph, that is distance time graph. So the two graphs, although they look similar, they are different because first is VT graph and second is ST graph. Although we may feel that they are similar, but they are not similar. These graphs represent what? They represent motion of two different bodies. So, if we look at the first graph, the graph OABC is a complete graph of the body which is in motion, which is represented by it. As it is a VT graph, and we can see that OA part represents motion in first t seconds. So OA is straight line inclined to time axis, which means that for the first t seconds, the body is in uniformly accelerated motion because VT graph is straight line inclined to time axis. Then in the next t seconds, that is from t to t, it is represented by AB. Motion is represented by AB part of the graph, and since AB is a straight line parallel to time axis, it means that between time t to 2t, the velocity value does not change. It remains constant, and it is mentioned here that the velocity remains V0 during AB part of the graph. It means in time t to 2t seconds, the body is in uniform motion, because in uniform motion speed remains constant. And we know that Vt means it can be speed time or it can be velocity time graph, and as it is not mentioned, we'll assume that the body is moving along a straight line, so we can use any of these two terms. Okay. Now, so OA represents uniformly accelerated motion, then AB represents that the body is in uniform motion. BC is again a straight line inclined to time axis, but this time it is having negative slope. And we can see that V is decreasing. So, since it is a straight line inclined to time axis, it means velocity is changing at uniform rate, and since it is negative, it is having negative slope, and since that is V is decreasing, we can say BC represents uniform retardation. So motion of the body is, in the first t seconds, it is uniformly accelerated motion with positive acceleration. In the next part of the journey, that is AB part of the graph, that is representing the motion from t to 2t seconds, it is uniform motion of a body, and then from 2t to 2.5t, it is representing uniform retardation. It means uniformly accelerated motion but with negative value. So it is a case of uniform retardation. Now in the second graph, as it looks similar, but as it is a ST graph, so let us analyze this graph also. OA part shows that ST graph in the first t seconds is a straight line inclined to time axis, which means in the first t seconds, S is proportional to t, or equal distances are covered in equal intervals of time. So OA represents uniform motion of a body. Okay, and AB, it means this part of the graph is representing the motion of the second body between time t to 2t seconds. As it is a straight line parallel to time axis, it means that distance covered is not changing. Distance covered is not changing, it means the body is at rest. Okay, so during the time t to 2t seconds, the body is at rest as distance covered remains constant. Now come very important point. Let us see the last part of the graph BC. BC represents motion of the body in the time t2 between the time t2 to 2.5t seconds. Now in this part of the graph, we see that distance is covered at a uniform rate and it is decreasing, but you know that with the time distance can never decrease. It means we were considering this graph as ST graph as distance time graph, but it cannot be distance time graph because distance can never decrease with time. So it must be either displacement time graph or it must be position time graph. Position time means position of the moving body from the origin is mentioned and it is representing that. So the second graph is ST graph is not a distance time graph. It can be displacement time or position time graph. Remember that. Now in the last part, that is BC part of the graph, represents that since it is a straight line inclined to time axis, it means that the body is having uniform motion. But displacement is decreasing. It means that the body, if it is displacement time graph, we can say that the body is moving towards its initial position. And hence, its displacement is decreasing. Or even if it is position time, it will infer the same thing. So, we have seen that first two graphs, although they look similar, but they represent motion of two bodies which are exactly different. First body during the first t time is in uniformly accelerated motion and the second body in the first t seconds is having uniform motion. In the time between t to 2t seconds, first body is having uniform motion and the second body is at rest. And between time 2t to 2.5 seconds, we can see that the first body is having uniform retardation or uniformly retarded motion. We can also call the uniform retardation as uniform deceleration. Remember that. Okay, or uniform acceleration but having negative value. And in the second case, although the body is having uniform motion, but we know that BC part shows that this cannot be a distance time graph as distance time can never be, distance travel can never be decreased with time for a body in motion. So from the third part, we come to know that the second graph is either a displacement time graph or a position time graph, but the third part represents that the body is in uniform motion. It means it is moving at a constant speed towards its initial position, decreasing the displacement magnitude, and finally S becomes 0. It means that position is same as the original position, final position is same as the initial position, or displacement becomes 0. Okay, so distance travel can never be 0 during when the body is in motion. So during the motion of the body, distance travel can never be 0. So we can say the second graph can never be distance time graph. Now, secondly, let us see what are the things that we can find out from these graphs. Now, in the first case, we know that OA part slope. OA part slope means it will be value of V0 at time t divided by t, that is V0 divided by t will give us slope of the graph in first time t is V0 upon t will give us acceleration value with which the body is moving in the first t seconds. Okay, and during AB part of the journey or between time t to 2t seconds, the body is having uniform motion with uniform speed or uniform magnitude of velocity v0, assuming that the body is moving along a straight line. And again in the BC part of the graph, we see that is between 2t and 2.5t. We can find out the slope and give the value of retardation. It means again we will find the velocity difference between B and C, that will be 0 minus v0 divided by time interval. So 2.5 minus 2t, that is 0.5t. So once we know the value of t, we can find it out if we know the value of v0 also. It means 0 minus v0, that is minus v0, divided by 2.5t minus 2t, that is 0.5t. So we can get the acceleration value from the BC part of the graph. Its slope gives us acceleration, and we will see that it is negative. And if we are asked what is the value of retardation, we will always write the answer in this case without the negative sign. Acceleration value, we'll put the negative sign and get the answer here. And for retardation value in this question, for the third part, we will write it without negative sign. I'll write it on the board and show it to you. Now in the second graph, from the first part, that is OA part of the graph, if we find its slope, that is S0 upon t. Slope is S0 upon t. Perpendicular upon base, we can say, or y2 minus y1 upon x2 minus x1, which means S0 minus 0 upon t minus 0. So S0 upon t will give us uniform speed with which the body is moving during first t seconds. And then between t to 2t seconds, we know the body is at rest at distance S0 away from the origin or having displacement S0. Now, after time 2t, we know that the body is again uniform motion, and we can find the speed with which the body is moving towards its initial position by finding the slope of this graph, and slope of the graph will be again 0 minus S0 divided by 2.5t minus 2t. So it will be again now negative. So negative because if we consider that this is it cannot be distance time graph, as I've already told you. It means it is a displacement time graph. So velocity is coming negative, as in this case negative velocity indicates that the body is moving in the backward direction towards its initial position. So I'll just write it on the board. Wait for a second. So just look at the graph and look at what is written on the board. So we see here that OA represents uniformly accelerated motion in the first graph, and the slope of the first graph during OA part gives us acceleration A, which is given by V0 upon T. And you can write the unit also, meter per second square. AB part represents uniform motion with speed V0, and BC part represents uniform retardation, and if we find the acceleration is again given by the slope, that is 0 minus V0 upon 2.5t minus 2t, and we get the acceleration value as minus V0 upon 0.5t meter per second square. So here we are getting the negative sign, and if in the question, if in any MCQ it is asked what is retardation, so we'll write it here without negative sign. So it is same as same as acceleration, that is V0 upon 0.5t meter per second square, but without negative sign in this case. Now in the second graph, if we look at the second graph, we know that now it represents displacement time or position time, and you know it cannot be distance time graph, and I hope the reason is clear to you, as distance traveled can never be decreased with time as represented by BC part of the graph, so it can never be distance time graph. In this case, OA represents uniform motion with velocity, magnitude of velocity. Yes, how will you find velocity magnitude? By finding the slope of the graph, that is S0 upon t meter per second. And AB part of the graph represents that the body is at rest, and BC part of the graph represents that the body is having uniform motion, but now with velocity, you can find out the velocity by finding the slope of the graph and by using y2 minus y1 upon x2 minus x1, where x1, y1 are coordinates of point B and x2, y2 are coordinates of point C. We get V is equal to 0 minus S naught divided by 2.5t minus 2t, which is minus S naught upon 0.5t meter per second. Okay, so we are getting, you already know that velocity, any vector can be positive, negative. So it is coming negative. So maybe here, why it is coming negative? Because the body is now moving backwards towards the initial position. I hope the graphs are clear to you, and now you can do the analysis of the graph properly and you can infer the kind of motion represented by such graphs. Straight line, a line, when graph is a straight line parallel to time axis, if it is ST graph, it represents that the body is at rest, but if it is VT graph, then the same straight line parallel to time axis, this nature gives us that the body is having uniform motion. So we'll continue with this in the next video. Hope it is clear to you. This is very, very important for you, as the concept is very, very important. Okay, so goodbye to all of you.